Hello everyone. Today I'll be talking to you about sorting and search algorithms. My name is Teo. I'm a professor and strategic initiative and innovation director at Rochester Institute of Technology. First thing is I would like to talk to you about search. Search is very frequently used before I talk about the sorting. Okay, let me. Okay, so today, searching algorithm, I'll be talking to you about three different types of a searching algorithm here, and they're linear, binary, and interpolation. There are a lot more searching algorithm out there, but I don't have the time to go over all of them. And you should have to search a lot of the search algorithm using Google. So these are the basic fundamental search algorithms available. Okay. For linear search this is a pretty easy search. It's a basic and the simplest search algorithm. Um, a search is a value from a list. It searches in the sequential order until you find that value or the end of the list is encountered. Once the end of the list is encountered, that means computer is not able to find it. On a successful search, it returns the index value, or else you will return -1, right? That means search is not there. Okay, so the index location, it's like an address of the value or location. So search is applied on unsorted list. It doesn't have to be sorted, but some search algorithm it has to be sorted first. But in this case, it's unsorted and where when there are a few elements on the list, it's a time consuming and it's very inefficient for the huge list. Especially these days, we're dealing with the big data, right? We're talking about not just the megabytes of data. We're talking about a couple of thousands gigabytes of data sorting through. It can be very time consuming, even with very high power, processors as well. So you gotta pick the right algorithm to search what is best for you. That depends on your application. Typically, you don't want to make it too complex. You can use a linear search, relatively a small amount of data, and you don't want to, have deal with more complex search algorithm. And this is fundamentally easy to do. So in linear search, what happened is it goes through from the beginning. Like this could be the address of the location, right? It start with it's looking for um, number 12, okay, and it looks at the first one 8, then goes to 7. It's not there. 15, it's not the right one, okay. And then it goes to the next one is 12. You find the right one. So key search. Basically, when you look at the Gantt, some kind of, this is a flow chart over here. Initialize. You continue to loop until you find the right one. Okay. Basically fundamentally easy to do. So when you talk about the binary search, it improves over a sequential search, which is in the more of a linear fashion, right? In this case, in binary search, you have to sort it first. It's faster than a linear search in some sense, but you have to consider you have to sort it first. Then sorting, it can take a good amount of time, but next part of it, I'll be talking about how to sort. It's basically employ a divide and conquer, and approximately middle of the element is located, its value is examined. It's always looking the middle. If the value is too high, then value on the middle element of the first half of array is examined. So here's the beginning, here's the middle, here's the end, right? So in the middle, it looks at if it's too high, you look at the below, number, whatever the number or value, it should be less than the middle because the middle number seems to be too high, right? So if value is too low, then value of a middle element second half already checked and procedure is kind of repeated, okay? So in this case, I have a more of a graphical version of this. As you can see on the, here, as you can see, the address is a location array 0, array 5, array 11. So it has a 3 first, mid, and the last. But remember, all of this number has to be, sorted first, okay? So target is a 22. So it looks at the, 0, 5, and 11. So it looks at then, when you look at the, array 5, then it's 21 since it's sorted. So it cannot be anything lower lower than, array lower than 5, right? Or as you can see. So what it does, it blocks out the array right here, as you can see. Then then he works with whatever the upper part of the middle, right? So looking at this, there's the upper part, 6, look, array location 6. I'm sorry, here, array location of 6, 8, and 11 here. So this is the middle. So looks at the middle first. It's a 62. So that what that means is looking for 22. So it's less than 62, right? So whatever that, if 62 and up, you don't need it anymore. You don't need this anymore. So you will black that out. Okay, black that out. So in this case, then you get first, middle, and last. Last is a 7, first is a 6, and the middle is is the first one as well because only there are 2 numbers left. So when you compare that, 22 content of the value 22 here is equal to the 22. What's it looking for? So it's basically it's divide and conquer. You divide it up, then you slowly merge into the number that you're looking for. Okay. So that's binary search. More when you look at the interpolation search is assuming the linear distribution of the keys in array, as you can see here. Here's the key. So in the middle equals low plus key arrow high minus low, and an array of high minus array of low. Then you calculate it. And so the array of 2 is 3, which is the key value. So we perform this calculation to find the exact location of the keys you're looking for, because this has to be in the in the order first. Then using all of this calculation, you should have to find the location here. So in interpret research, mid equals high plus low slash 2. Why the middle element? Because it's always you don't want to go from the first or you don't want to go from the west. Just like a binary search, it's always more efficient to go start from the middle. Okay. What if you had a better estimation of the location key, then you need to move to that better estimation. So binary search always check for the value in the middle, but the interpolation search may check at a different location and the value of the element being searched. So interpolation search uses the value of array of low, value array high to estimate the position as key, known as a probing. Okay. So those are the 3 different searches I just have explained here. So what I want to go to next is sorting. Sorting is another part that I would like to talk about. So I've been talking about all of this different types of sorting algorithms available. So let's start with bubble sort. So bubble sort works by, basically comparing each item in the list, item on the next, swapping. Okay, so algorithm repeat the process of passes all the way through the list without swapping any of the item. This causes a larger, larger value to be bubble to the end of the list, and while small value, comes front of the list when you keep doing this process. So a bubble sort derives a name from the fact that smallest data item bubble up to the top of the source array. It's basically what happened is that over here, this is bubble sort. Okay, so he looks at both this number, again, first two, 14 and 33. This is in the right order, right? So you don't have to really change the location of this because those two are in the right order. So when it goes to the next one, after leave goes to the next one, is when you talk about the 33 and 21, and you notice this is that 33 is higher than 27. So it changes the color, it sets the switch, right? It sets the switch. So it switches to 27 and 33. So it gets 14, 27, and 33. Okay. Then it goes to the next items are 33 and 35. Is it in the right order? Yes, it is in the right order. 33 is less than 35. Okay. It's in the right order. Then it skipped. I mean, not skip. It's move on to the next item. Is kind of like move over one space. It compares. Sorry about that. It compares the 35 and 10. This is clearly 35 is a lot larger than 10. So it sets to switch, right? It sets to switch. So 10 and 35 switch, then becomes 10 is here, 35 here. Okay. So, it's a 14, 27, 33, and 10. Okay, so it goes on the, this is first iteration, then goes on the second iteration. Later, he finds that, 33 and 10 needs to be swapped. It goes through, you repeat the process of 14, 27, 27 and 33, it does not need to change. So it goes to 33 and 10, then it does need to change, right? So it changes. 10 goes here, 33 goes here, as you can see here. Okay, that's a second iteration. So when you go to third iteration, you do this again, go from 14, 27, okay, 27 and 10. 27 is a lot larger than 10. It switch. You switch to here, 27 come here, 27, 33. It's in the right order, 33 and 35. So this is a third array, iteration. Okay, the final iteration, what happened is that 14 and 10, it switches, right? It switches 14 and 10 switches, then you become 14, 14, 27. What do you call that? It's in the right order. It doesn't need to switch. So as you can see, it becomes the sort array. Okay, this is the flow chart for this sorting algorithm. Okay. Another type sorting algorithm is a selection short. Selection short algorithm sorts an array by repeatedly finding the minimum element, as I can say, repeatedly finding the minimum element, considering the ascending order from unsorted part and putting in at the beginning. So maintains two different subarrays, sorted one, unsorted one, and in every iteration of selection sort, minimum element from the unsorted array is picked and moved to the sorted array. Okay, so okay, let's go see what does it mean here. Okay, so finding the minimum element here. Set the min equals 0, search for the minimum element in the list, and swap the value at the location minimum. So what happened is, 1 here, 11 here, 25, 22, 20, 12, 22, and 64, right? So the first one is 11 and 25. It's, it's in the right order, right? Okay, then you move to the next one. Next one is 25, 12. Then 12 is clearly the closest, so it moves 12 the front of the 25, right? Then also compares the 25 to 22, and 22 is smaller than 25. So what happened is it moves 22 to 22 to 25 location. Okay. After that, 25 and 64 is in the right location. That's how being sourced. As you can see, it's 11, 12, 22, 25, and 64 completed. Okay. Okay. So that's a more of a selection algorithm, and this happens to be the flow chart, okay, of the algorithm. Okay. So when you talk about the insertion short is in place of comparison based algorithm, here's a sublist maintained which always is sorted. Low part of the array is maintained to be sorted. The element which should be inserted into sort that sublist has to find the appropriate place, then it has to insert it there. That's called insertion short. Okay, let's talk about what does that mean using graphical way. Yeah, okay. So as you can see, if the first element is already sorted, return 1, you pick next element, compare the all element is sorted sublist. Okay. So yeah. And shift all the element in the sort list that is greater than value to be sorted. Insert the value, repeat until sorted. So what does that mean is, let's take a look at it. It's a 14 and 33, 27, 10, 35, 19, 40, 44 here. To be sorted, then the 14 and 33, when you take a look at it, is it in the right order? It is in the right order. Then moving to the next one, 33, 27, so 27 is lower. You'll switch to 23 and 27 here. As you can see, is moving the 33 over here. Then go to the next one. The 3310 is located here. Clearly, 33 is larger than 10, right? Is it 33 larger than 10? So it sets to move the 10 into the 33 position, which becomes 10, 33 here. Okay. So once you moved, so you have to, this 10 is smaller than 33, but we have to compare the rest going down. Okay. So 10, 27 is 10 is smaller, say move the 27 to over here. And then after that, the 10 compares to the 14, right? So what does it mean is it goes to the right, comparing after it switched, then you have to check the, all the previous locations, okay? So previous locations, so looks at the 10 and 14, 10 is smaller than 14, so it becomes a 10, 14, and 27. And then they proceed further on. So when it comes down to 19 and 35 here, it will switches. The 19 will be compared to 33 again. 19 move down. 19 will compare to 27. The 19 will move down again, and the 19 will compare to 14, which is the live location. You will insert it in here. Okay. That's how it works, basically. So, so quick sort is based upon partitioning of an array of data into smaller array. Large array partitioned into two array, one of which is holds a value smaller than specific value, say pivot, based upon which partition is made. So another array holds a value greater than pivot value. Okay, let's take a look at. I think I have a graphical view here. Okay, so pivot here it depicts the high and low. Okay, high and let's switch it right because you're 26. Then you move down here, move up here, then move down here. You compares it and you switches it. Okay. And this one in 19, he switches it in 19 over here, 42, then 10 and 4, this is correct, right? So you will divide into two partitions, right? So two partitions, and then you do the same thing again, pivoting, okay? You start with the, pivot from the one end to another, pivot, compare, then they compare, and it compare, not this next to it, you compare from the high and the low. Then if low is bigger, you switches the number with high. Okay, so you continue to pivot again. And while you're doing that, you eventually you'll be sorted as I indicated before. Okay, and this is this is a flow chart of that. So share sort is a little bit different. It's a highly efficient sorting algorithm. It's based upon insert sort algorithm. Insert sort algorithm. It's all related. When you look at the insert and those all algorithm, it's related. It's avoid large shift in the case of insertion sort. But if a smaller value is far right, has to be moved to the far left. Okay, so uses insertion sort in a widely spread element, forced to short them and then short the less widely spaced element. Let's talk about what I mean here. So, color coded is done to, make it realize it's easy to understand on the top here. Basically, instead of comparing the number right next to one another, so what this does is sort every fifth element. So it compares 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay. 1, 2, 3. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Okay. So what this is sort every fifth element. Let me think about here. 1, 2, 3, 4, 5. Now when it compares 5 and 1 and the 1, 1, 2, 3, 4, 5. It compares the 5 and 1. Okay, 1. Okay. So initialize the value of h, divide the list into smaller sublist equal interval h. So you divide into small okay. So when is that 1, 2, 3, 4, 5. So 5, 1, 1, 2, 3, 4, 5. So it compares a 5, 1, and 18, which is the smallest, a 1, right? 1 is moved here, 5 moves over here. Okay, share sort. Okay. Then the okay 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. I think I might have a, it's a share sort is a highly efficient run based on it avoids a large shift edge case. So insertion short is a smaller value is far right, has to move to the far left. Which is insertion sort on the, right element. So basically, this is the number is being displayed. It sorts every fifth element. It shows like this. So what does that mean is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, okay. Okay, so from starting here is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it compares every fifth element and swap one another. And this one is compare every third element and compare one another. Eventually, you will have a normal insertion short. Okay, so compares every fifth element here, every third element here. So then you get the normal insertion short. Also, the heap sort is one of the best sorting method being in place. No quadratic or worst case scenario. Heap sort algorithm is divided into two basic parts, creating a heap, and then the sort array is created by removing the largest and small element from the heap, insertion into the array. So it's a you construct after each removal. So what happened is like a 35, pick one number, then 33. 33 is smaller than 35. It's okay. But if this is higher, it switches. Okay. As you can see, the low level number always needs to be smaller. But if it's large, they continually switch. As you can see, 44, the 44 over here. So whatever the number 31 here comes out here. 31 is smaller than 40. It just stays here. Okay. So whatever the number is, high at the low level, it was always climbing back to the top, to the top. Okay. So all the low number it should stay on the bottom. So based upon that, and you should have to sort the right number, right into, the highest number on the top and the, lowest number on the bottom. Okay. This is the, so sorting technique is based upon divide and conquer technique. Is a merge sort is divided into array of equal half, then combine them into sort manner. As what is it divide? Continue to divide and put it together. Okay, what does that mean is that step one is if it's only one element in the list is already sorted, then return divide, list recursive into two half until it can no more can divide. Until no more can divide, merge the smallest into the new list, doing the sort order. So what happened is here is the whole number, right? Then you continue to divide. This number set them, they divide into two. This can be divided into, two sets again, because two of each number. Then this number is divided into two, individual number, as you can see here. Okay. So then put it together, 14 and 33, 14 is a lower number, it stays. But when you look at the 27 and 10, 10 is a low number, it switches. 35 and 19, when you combine it, it switches because 19 is smaller than 35. 42, 44, it stays the same. Okay. Then you combine these two. these two into one large rectangular. Within here, okay, it switches back and forth. So 14, 33, but 10 and 33, 10 is smaller. So we move here, 10 and 14. So 10 is smaller, 14 moves out, okay? Then over here too, 1935 is okay, 35, 42 is okay, 44 is okay, stay the same. But in this case, as you can see, is number of no, sorting has changed. So when you combine those two here, as you can see, that you sort it out everything, once you combine. So a 10, 14, because 19 is smaller than all over here. 19 goes here, then 27, the 33, 35, 42, and 44. So when you do this, combining at a time should be much, much efficiently and compared to what's in the beginning. So it's a divide and conquer and, putting it all together, okay? All right, everyone, this is a lecture about a search and sort algorithm, and thanks for listening.